Okay, I am sending this video out because I know that a lot of parents have questions about the strategies that their children are using for multiplication and division, and it's my hope today that by working on this and sharing it with you, that you will be able to help your child at home. So these aren't the only strategies that we know, but these are the most common ones we're using right now. We're not totally ready for the traditional algorithms of multiplication and division. Some of us are there, but for the most part, we're splitting and we're trying to chunk our numbers into friendly numbers to work with as we try to multiply 2 or 3 or 4 digits times 1 digit. So I'm going to start with 48 times 7. And what the children would do when they see this is they would split 48 into 40 and 8. At this point, then, the kids would write something probably that looks like this. 40 times 7 plus 8 times 7. So what they've done is they've broken the bigger number apart, and they're still multiplying each part by 7, which is going to give us the same product as if we were to do it the traditional way. Another strategy that children are using right now is that when they see, like for example, the 40 times 7, they're saying to themselves, forget about the 0 on the end of the 4 and add it back on later. Or at least we want them to be taking those mental shortcuts. So I look at this and I say 4 times 7 is 28. There's a 1 0 at the end of the 40, so I'm going to put 1 0 at the end of my product. Then 8 times 7 is 56. At this point, then, the kids would look at those and they would add them together. They might even stack them on top. Some would do it in their head. Either way is fine. So 280 plus 56 is 336. And that's what we would do to solve that problem. If our problem were larger, say 3 digits times 1 digit, we would do something very similar. We would break 382 into 380 and 2. And the reason we do that is because we know that it's very easy to multiply by multiples of 10, because you can forget about the zeros and then add them back on later. So if you didn't want to write it with the parentheses, or your child was confused about where to put parentheses in the problem, they could do something as simple as 300 times 9, 80 times 9, and then 2 times 9. So when I think 300 times 9, really in my head, I'm saying what's 3 times 9, and then I'm going to stick those 2 zeros on at the end of my answer. I know that 3 times 9 is 27. There are 2 zeros in 300, so I'm adding 2 zeros to my product. 80 times 9, again I'm thinking what's 8 times 9, 72, and then I'm going to put that extra 0 on at the end, and then 2 times 9 is 18. So now I need to add these up. I didn't do a very good job of lining them up, so I'm going to write them one more time, just as I would ask the kids to do if they weren't lined up correctly. 2,700, 720, and 18. When I add them all together, I get the product of 382 times 9. So the product is 3,438. Those are strategies we're using for multiplication. Like I said, some of us are ready for the traditional strategy, which is what I learned when I went to school. And by the end of the year, we'll all be using that. We're starting with this because we believe that it helps students understand multiplication better. As far as division goes, we haven't learned the traditional division, long division algorithm either. What we're doing right now for division is we're using number combinations that we know, multiplication combinations that we know, to help us divide. So the way I teach my kids about division is that when they see a problem, I tell them to put the big dog in the doghouse, which in this case is 91, and make the little dog sleep outside. So what we're trying to figure out is how many times will 7 go into 91. At this point, I'm asking the kids, is there a multiplication combination that you know that will get you pretty high, like maybe close to 91, as close as you can get with being able to do it in your head? And very often we start with whatever the divisor is times 10. So that's what I'm going to do here. So I'm going to go 7 times 10. And what that would mean is that I could subtract 70 from 91. When I do that, I have 21 remaining. So now I need to be thinking, can I pull out any more groups of 7? And of course I can. I can do 3 groups of 7, which is exactly 21, leaving me no remainders at all. When I get to this stage, I'm trying to figure out now how many groups of 7 did I take away altogether? How many groups of 7 did I pull out? And so I have the kids add up how many groups they took out. In this case, we took out 13 groups of 7, and that answer goes on top. So we're writing it in a format that looks similar to long division, but we're not exactly doing long division yet because we're not quite ready for it. We're still thinking in terms of multiplication. Now, if your number was larger, like 542 divided by 3, we would start very similarly. We would put the big dog inside the doghouse, make the little dog sleep outside, and instead of thinking 3 times 10, man, it would take me forever to subtract 30 from 542 until I got down to close to 0. I might think, well, could I do 3 times 20? Could I do 3 times 30? Could I do 3 times 100, which is what I'm going to do here. So if I do 100 groups of 3, I can subtract 300, and that leaves me with 242. I can't subtract another 100 groups of 3, but I might be able to subtract maybe 50 groups of 3 or 60 groups of 3. If I were a student right now, I probably wouldn't be able to think so many steps down the line. That wouldn't be the first thing that comes to mind. So I'm just going to say, well, I got 100 groups of 3, let's try 50. So when I do this, I'm thinking, what's 3 times 5? It's 15, and then I'm going to add the 0 on at the end. So the problem now is 242 divided or subtracted, take away 150, which leaves me with 92. At this point, I need to keep subtracting groups of 3. I know 3 times 30 is 90, so that's a really great place for me to start. If I take 90 away from 92, I'm left with 2. Now, I can't take any more groups of 3 out because there's less than 3 left, and we know that those are our remainders. Before we get to the remainders, though, we need to add up how many total groups of 3 we were able to take out of 542. 100 plus 50 is 150, plus 30 is 180, with 2 remaining. So these are the techniques that your children are using. I know there's a lot of sometimes confusion at home when parents are trying to help, but they don't understand exactly what the child is learning at school. And this is my effort to help clue you in and fill you in on some of the things we're talking about at school. By the end of the year, I hope that your child is correctly, efficiently, and effectively using traditional strategies, the strategies that you and I learned. And until then, we're going to simplify it by using combinations we know to help us solve the problem. If you have any questions about this or you need more explanation or you want to talk about it, please feel free to call or email, and I'd be glad to help you anytime that I can. Okay? Thank you.